great to be here this afternoon. I'm going to be talking about TypeScript and Vue at Politico. But before I get too far into our journey there, I want to start with a quick demo of kind of the cases in JavaScript in Vue that encouraged us at Politico to try out and now fully adopt TypeScript across our repository. So we're going to do that with a quick demo. Today is Super Tuesday. For those of you from outside the US, it's the time when a lot of our states vote in a primary election for the Democratic candidate for president. And Politico is a political news organization, so this sample component will display candidates who are on the ballot in a given state. We have a data property, the current state that we're going to be interested in. That'll be filled in later. And then we have props, in this case, just an array of candidates. When I wrote this code on Saturday, that array would have been a lot longer. Computed Democrats, we're just going to filter out the people who have Democrat as their party. And then this is where things get at least a little bit complicated, and this is what we're going to dig into in terms of some of the problems we've experienced. So this is showing the Democrats where all the states that they're on the ballot, in that array, the current state is included. Finally, when the component is created, let's set our current state, and we'll do that. Maybe this is a Vuex method or a call to an API. Cool. So this is what it looks like in VS Code. Oops. So now we're in the JavaScript file here, and I want to show 3 pain points that we've run into at Politico in our experience of working in a JavaScript repository. So let me start by, oops. So if we're going to say the first case that we might be interested in is when we write this code originally. So this is a data-heavy application that has lots of information about candidates, and we're interested in filtering out Democrats. But as soon as we start typing here, we notice that as opposed to TypeScript files or maybe heavily annotated packages, we're getting no information about what the type of Democrats is. And this is a function of the way that Vue 2 is written, which is that as it stands as a simple set of object properties, TypeScript and VS Code can't know type annotations for our component options. So I'm trying to type filter here. I'm getting nothing. Similarly, as I try to filter on Democrat, I get no information about the properties available. These are just autocomplete things. So this was our first problem. When we write the code originally, we're not getting nearly the level of IDE assistance or TypeScript help that we would be interested in. So let's uncomment this and talk about problem number 2 that we started running into, which was that as we came back into components, we found ourselves frustrated that we got very little assistance in terms of understanding the intent of the original developer. And so, while I'm over here on, for example, current state, I'm getting no information about the shape of current state and what properties are available on it. So if I'm a developer who did not write this code originally and comes back into it, I'm getting no assistance understanding the intent of that original developer. So that was problem number 2. And finally, problem number 3 is what if something changes? What if something changes outside this component? And we want to know about it as soon as possible. If it's just JavaScript, sort of by nature, when the only time you'll find out about that issue is when that JavaScript gets sent to the browser and something breaks for our users. And that, at the enterprise scale of developing these data-heavy front-end applications, simply won't work, especially as we want to make use of CI/CD pipelines. So with those 3 things in mind, let's take a look at the TypeScript version of this component. It's the exact same. You can tell it's a TypeScript component with this lang equals ts at the top and this view.extend instead of a simple object. And that's pretty much all you need to get started with a TypeScript component. After that point, starting to add your annotations to help TypeScript understand what's going on. So remember that first problem of what do we want to do when we're developing a method originally and we want to get access to information about our types. Now when we do this.democrats, we start getting information specific to an array because TypeScript already knows Democrats is an array, which is great. So let's filter, and for each Democrat, let's check Democrat dot, and now we have access to these type annotations for the properties that are available. So this type of enhanced experience in an IDE is what has been so useful for us at Politico. So that's case number 1, when we're originally developing. Case number 2 is it's some other developer hoping to add an enhancement, or it's me 3 weeks from now, and I've totally forgotten what me 3 weeks ago was thinking. And so when I come in, I want to see what is the shape of states, what's going on there. And so I'm just going to press F12 here, which is go to definition for TypeScript when it's enabled. And I get to go to the states property on a candidate. And if I'm interested further, then I can see that there are, that state itself has properties of abbreviation and name. So that annotation and helpful navigation of existing code has helped us solve problem number 2 of coming back into code and making sure it still feels maintainable by being accessible to all developers. So then finally, problem number 3, what if something changes somewhere else and we want to make sure we catch that error before it gets to a user in a browser? Let's force that as an example, F12 on abbreviation. Say that for consistency's sake, this is going to be renamed to abbreviation, and we'll save that. If this happened in a JavaScript component, maybe it's some ticket we weren't aware of. The first time we would hear about this is a user complaining that something's not working. But here with TypeScript, we get this super wonderful error message that property abbrev does not exist on type state. And to fix it, I just start typing, and I see, it's abbreviation now. So this has really changed our mindset at Politico in terms of how we think about errors. Errors are now something to look forward to in a way, because it means we're catching things before a user will ever find out about it. That's been huge for us, and it's reframed a lot about how we think about our front-end development pipeline at Politico. So I'm Jack. I work at Politico. 3 years ago was our first experimentation with Vue. Politico has both the news site, and then they have a subscription platform with a lot of data-heavy applications. And so for one of those, a campaign dashboard, which feels appropriate today, they experimented with Vue and loved it. But as we started expanding to other aspects of our data applications, we realized that there are certain things, like we just demoed, that really start to feel limiting when you're only in a JavaScript environment. So around when I started at Politico, we started experimenting with TypeScript in a repository. We've run with it, and it's now all of our Vue applications are written in TypeScript, and it's been backfilled into a number of our existing applications. Today, then, we'll talk about the pain points that we've attempted to solve with TypeScript, the solutions that we've found work well for us at Politico, and hopefully will work well for you here. Some of the lessons that we've learned of the things that are Vue-specific in terms of it's kind of tough to do this with TypeScript and Vue, so we want to address those. And then, importantly, there are some great news or great items of news that a lot of which we've heard about today, especially in terms of the composition API and some tooling that's available for TypeScript components. So this is the part of the presentation which I'll attempt to breeze through fairly quickly, because I think a lot of us have sometime in the last 5 years understood roughly what this buzzword is. TypeScript is static typing for JavaScript, whereas JavaScript is dynamically typed, meaning any variable can be any type of object, string, number, array. TypeScript forces you to say, for this variable, it should only have this shape, or it should only ever be an array. Microsoft has always sold TypeScript as JavaScript that scales, and I like to refer to it as enforcing data shape. I think that's a useful way to think of its role in your application. This is what we'd like to avoid. I don't want to be this person with the tuba. So for this presentation, I'll attempt to avoid just screaming things about TypeScript at you. There will be screaming, but we'd instead like to focus on how, in a Vue-specific context, this might work out as a pathway for your own company. This was an article that Dan Abramov wrote in 2016. He called it "You Might Not Need Redux," which was interesting because Dan wrote Redux. It's a state management tool primarily used in React. Vuex is heavily modeled on it. But he wanted to convey that the conventions that are forced on you by using Redux may not be worth the effort if your application doesn't need them. And so there's sort of a similar thing here to avoid being the tuba person with TypeScript. There are cases where you definitely likely don't need it. For example, if it's a small application. Or if your application is really UI heavy and data light, if it's more about displaying and maybe animating content rather than modifying and manipulating data. If it's only you on the application, you may not need or benefit from TypeScript. And finally, if you're considering retrofitting an existing application that's working well up to this point, you may not need TypeScript. It may not be worth the effort. I'll talk a little bit throughout about why you may still consider it in these two cases. At Politico, our news application, responsible primarily for showing articles, was originally written in JavaScript, and for the longest time, 6 or 7 months after we had started using TypeScript, we avoided any retrofitting of TypeScript into that application because it seemed to be working just fine. Then at that 7 or 8 month mark, we started missing some of the features that we were getting in our newer repositories, and we've slowly backfilled certain TypeScript features into certain components and files. So let's talk about these pain points. Let's talk about the solutions that we've experienced. I'm going to be talking about this in what was test case number 1 for us. It's an application that we call Congressional Directory. It looks kind of like this. It's a way to search through members of Congress or members of federal agencies. So at the time that we were starting this, one of the things that we were most worried about was this IDE support. How can we make developing Vue components a better experience given all the functionalities that VS Code should have? With JavaScript, we're limited compared to traditional statically typed languages like Java or C# because so much of the abilities of the IDEs for those languages, so IntelliJ or Visual Studio, comes from their ability to say, when I define this variable, it will have these properties. And so I can make suggestions to you. Essentially, static types are what make Clippy work. In this case, Clippy's asking if you would like help with defining your class. So in the case of VS Code, this was around 5 years after TypeScript created. One of their co-creators wrote a post explaining the origins. And essentially, it came entirely because at Microsoft, developers who were hoping to get these experiences that they had when writing C#, for example, they couldn't get that with JavaScript because it didn't have these types. And so that was the origin of TypeScript, was essentially to enable something like VS Code. So for Vue, it's a little bit of a paradox that I find kind of interesting, which is that if you were to open a standard .js file, at this point, the integration in VS Code is so good that most of the integration and the widespreadness of TypeScript libraries, most of the libraries and the code that you import would just work and would tell you a lot of useful things about them, even if you're in a JavaScript file. But because Vue 2 wasn't designed with this type inference in mind, where VS Code can, or where TypeScript can just figure things out about your code, that means that if you're writing a JavaScript component, you really don't get anything. I showed at the beginning a little bit. Everything will show up as an any. It won't tell you any type information by default. And so in order to get any kind of real experiment going, you'll have to try this lang equals ts, do the vue.extend, and try that out in a few components. And when we did that in this directory application, we were kind of stunned. And it was really exciting to have that type information. So the next thing that we were hoping to do is match our complex hierarchies, our data models. I mentioned that the Politico Pro applications that we work across, there's directories, there's regulations tracking. They have to track models like this, like a rule or a regulation. They have to track people in a directory. We have to have models for legislation or bills. We have to have models for search so that we can display search correctly, content so that we can display articles or contributors to those content. So all of these data types are things that have to be readily understood across lots of different components in multiple different repositories. And so we realized as we were starting this directory project that we needed a way to start getting some of that information while doing development. So here in this simple JavaScript file, I'm hovering over one of in this somewhat complex method, I'm hovering over bill.cosponsors, and I'm getting no information at all. This is the any that will show up so often in JavaScript Vue components. As opposed to, if I change that same component to be TypeScript, I get a lot of information about what exactly cosponsors is, what the other properties are. And so that's been huge for us. We noticed it right off the bat with this directory application. We've continued to notice these benefits as we've moved forward. So what we want to avoid is this. This is what a former boss described their engineering role to me as, writing tomorrow's legacy code today. Often that's sort of what we're doing depending on how long your maintenance goes for a given project, but we can decrease or avoid that or make people not scared to come into a repository 3 months from now or 6 months from now or a year from now. We can improve that by making it really easy to pick up in any piece of code, all right, if I'm interested in this aspect of the component, where can I navigate to? Help me navigate to figure that out. And finally, catching development errors is something that we wanted to make sure we were able to do at build time versus at runtime. This was something that our backend team, and I think a lot of backend teams across companies, have gotten really good at already, which is continuous integration and deployment pipelines, where every time you make a PR, you run your tests or you compile your code against that. In Vue and JavaScript files, you can write tests that are super useful and very important, but the types of errors that come from typos or other code changes across your repository, those errors would slip through to your users if you don't have a step like TypeScript in place to do that type checking. And so you end up with a lot of this. Cannot read property of undefined, and it turns out it's code I wrote 2 weeks ago. The developer me 2 weeks ago really is not that great. So this is the type of thing we'd like to catch before it ends up in the user's browser. So quick example code, this is just a JavaScript computed method. There's something wrong in here. I won't make you try to find it, but that's the experience that often you come across is it's tough to see these things. And so this is what would happen. It would show up in your browser. Candidates.states is undefined. So you can see where this is coming from, but you'd never catch this until it's already with the user. And so you end up with nothing displayed in the browser at all, which is what we'd like to hope to avoid. Meanwhile, if you have TypeScript in the same component, all that we need to do is annotate what the return type should be. So now we get in Visual Studio, we get the states underlined already, and if we try to build this, for example, when you merge your PR and you run your CI/CD pipeline, the build will fail. It'll never even get to your QA environment, which is great. All right, so some of the lessons about what's worked well for us in terms of adoption strategies. This is our first 7 months of TypeScript at Politico. We started with 1 repository and 3 developers on it, and that went on for 7 months. The next point is when we added 1 more repository. So this was sort of intentional because we found it's useful to avoid friction in your adoption of TypeScript at your organization. That meant that we started out in a greenfield project where it was possible, so a new repository. This was useful because then it allowed us to pick up TypeScript best practices where possible. And a good example of this, we've heard it multiple times today, is mixins. So mixins pretty much just don't work in TypeScript Vue files because there's too much Vue magic involved in resolving what is this and what's available on this. But you can do things like use extends or use helper functions instead. And then if you don't have upcoming greenfield projects, it's perfectly OK to start backfilling TypeScript into an existing project. I would encourage liberal use of any. It's this TypeScript concept of I give up, essentially, on this type. And if you give up on a type, using any allows you to move past this frustration so that you can at least get onto the next component. Later on, as you're trying to enforce more type safety across your application, you will try to avoid any. It'll sort of be a code smell or a to-do, something that we can resolve as possible. So then what did our next year or so look like? So we hit this inflection point right around May of last year. And so now we're at from 1 to 9 repositories with TypeScript. We've gone from 3 developers to 18, which is all of our front-end team. And the decision that we made right around that inflection point was, A, TypeScript has worked really well in this directory project and the second new project as well. And we'd like people to, on our team, we'd like people to feel comfortable with the TypeScript, TypeScriptified Vue code. And so a recommendation there is, as you ramp up, to start adding everyone on PRs so that everyone can review this is what TypeScript code is. And to try to, if your team allows it, rotate people on and off of TypeScript projects. We've found the snowball effect has been so much more beneficial as we've had many devs who feel comfortable writing TypeScript as opposed to 1 or 2 who are very, very confident. And then quickly, so some highlights of the things that have worked really well in terms of tooling for us that we're really excited about. One, ESLint is a really basic thing, but there was a time when TypeScript had its own linter, TSLint, and only recently the TypeScript team decided they would switch over to what the ecosystem was already supporting. This means that our JavaScript components and our TypeScript components can live side by side now with no frustrating conflicts. When I gave a previous talk about converting an existing project to TypeScript, this was not the case, and I had to say at least a few times, like, you might not be able to do this easily because of linting, which is a terrible thing to have to say. VTI, so this is Vetur template interpolation. We'll look at this. It's the most incredible thing. And code gen tools, which we'll also talk about if those happen to fit your team. So this template interpolation, this is a setting you can turn on in VS Code right now. It's false by default. So I'd recommend you try it out if you have a TypeScript code base or a code base that you're working on adding TypeScript to. Up to this point, I've mentioned nothing about templates in your component code, and as of 6 months or so ago, that would be the end of it. There's no option to do this kind of type checking of your script tags and apply it to your HTML because they're separate. TypeScript cares nothing about HTML and understands nothing about HTML. So if this was going to happen, it was going to have to be a Vue-specific behavior of linking up properties available in your script tags to what you've written in your template. And that's exactly what the Vetur maintainers have done. And so this next slide is just like, brings tears to my eyes because it's so beautiful. In the template portion of this component, we're getting a TypeScript error, which means that you can now type check an entire code base and make sure that your changes not only haven't broken things in your script tags, but haven't broken anything in your template. And this works with v-fors and v-ifs and does all of that interpolation necessary. Which is huge for us and has been a major boon in terms of consistency and confidence of making changes across our applications. Vetur has also very recently broken this out into a package that you can run on a CLI, which means this same type checking can now be part of your CI/CD pipeline. This is in active development, but it already works, which too is quite fantastic. Finally, I want to at least briefly touch on the idea of using code gen tools if you're going to switch over to TypeScript, especially if your APIs for your backend happen to look something like this, or GraphQL in a way where the GraphQL schema is documented. Because we're using TypeScript, we can generate information about HTTP clients, both endpoints and parameters. And we can also get information about the response objects. So that means that when I start doing this candidate API, it's generated code which tells me for this HTTP endpoint, these are your methods available. For each method, this is what you need to pass in. And for each response, these are the properties that are available on that response. For us, this has worked incredibly well because our backends were already Swagger documented. If you happen to know that about your backends, please, there will be additional links here, or come find me. This tool has been probably our biggest productivity booster in terms of making sure that our back and front ends are kept consistent, and then that we're not duplicating type information across the two. So then the things that have been challenges, one is mixins, which we've already heard a lot, and the answer is sort of don't use them in TypeScript code. There is a replacement even with Vue 2, which is using extends for the most part, like extending from a base component, can work just as well as a mixin and is for the most part TypeScript friendly. But the larger thing that has been the question I've gotten every time I've talked about this topic is, what about Vuex? And the answer is, it's sad. So Vuex uses things like map getters, map mutation, map actions to take strings and then do view magic to the strings so that you get the right context to call in your component for Vuex. Meaning TypeScript can't understand those strings, and so you have to pick some alternative approach to Vuex. One is class components with decorators. For various reasons, especially the direction Vue 3 has taken, I probably wouldn't recommend this for new projects. Another is this package, which is essentially higher order functions that wrap your Vuex functions. And third, don't use TypeScript in components where you very much need to use Vuex. And this is a viable strategy, especially for backfilling TypeScript piecemeal into an application. At Politico, we use this type-safe Vuex library. It's actually something that we maintain, but I want to bring your attention to this quote about that library, probably the most expensive IntelliSense generator I've ever seen in app code, and this is from a coworker, and he's not wrong. It's a lot of boilerplate, and so we do try to avoid it when we don't absolutely need it. So bringing this full circle, if you might not need Redux, these are the cases where you might not need Vuex, and this is something that we've learned, and it doesn't have to be true across an entire application, it just has to be true in a given component. So if you only need local state, for example, if your state is only needed in a parent and it's direct children, or a child and it's direct parent, then that's very easy to manage locally. Or if you have global state that's constant and not changing, there's no reason to put that into Vuex. You can define that in an importable constant. So where we've landed on this for our applications is we use Vuex only when we most have to. All right, so just to catch at the very end, the things that we're excited about at Politico, Vue 3 and some tooling things. One is with Vetur. I mentioned the template interpolation. The one thing it doesn't yet do is make sure that you're passing in the correct object types for props, so that if a child is expecting a candidate prop, making sure that the parent is passing in a candidate. That's something that's coming, which is really cool. So it's been identified as something that will be doable with this template interpolation framework and is being worked on. So we're super excited about that. And then Vue 3, I won't go too much into detail because the summary is essentially by using the composition API, everything should just work from a types perspective. By getting rid of this kind of magical this context, it means that TypeScript will be able to infer your types in almost all cases. So this was written about the composition API. In other words, Vue's existing API simply wasn't designed with type inference in mind, and that creates a lot of complexity when trying to make it work nicely with TypeScript. Meanwhile, the composition API itself, instead of relying on the magical this context, a composition function relies only on its arguments and globally imported Vue APIs. So what's exciting to us at Politico about this is that we no longer have this paradox. Things will work just by type inference in most cases. At Politico, we'll still certainly be using TypeScript components because the type safety of compile time checks, for example, are really important to us. But I think that's maybe the parting message here is that even with the composition API coming, it's additive, like we've talked about. All the lessons that we've learned over the last year and a half at Politico are applicable now and will be applicable in the composition API. And we're really excited to make use of those in our most complex components, or especially in our components that it's most important to share state in a readable and reliable manner. So that's what I have for you. Please hit me up with any questions or discussions, things you've tried with TypeScript that didn't work nearly as well as you want to, or if you just want to yell at me about Vuex and wish that it worked better. I'm at Jack P. Koppa on Twitter. Thank you so much.